Well, let's create a vector using the range method of TensorFlow. So tf.range, and let's create a vector of 11 element. So 11, and assign it in a variable and name it range vector. Execute it and check it. Awesome. We can see all the elements here from 0 to 10, and the shape or length is 11. Well, if we want, we can make a sum of it. Make a sum of all the elements of this vector. And for that, we can use our for loop for index in range vector. And here we can get the elements, all the elements of range vector like this. Range vector and the index. Let's print it for now to check. Now let's declare one variable and name it sum of range vector. Initialize with 0, and here inside the for loop we can say sum of range vector equal to, let's delete this print method first. So sum of range vector equal to sum of range vector plus our elements of the vector, and we can shorten it using the plus equal to sign, which we have learned in our Python section, the arithmetic assignment operator. So we are saying sum of range vector equal to sum of range vector plus range vector of index. And outside of our loop, we can print the sum. Print sum of range vector. Awesome. We can see it's 55. We already know how many elements are there in our range vector, but if we want, we can count the elements. So we can simply declare one variable and name it counter, initialize with 0, and follow the same process, but every time we will increase up to 1. You can say counter plus equal to 1, and here we can print the counter. Print counter of elements and print counter. Do it again, and we can see it's 11. We can also check the number of elements using the size method of TensorFlow. tf.size and range vector. Great. We can see the number of elements is 11. And now we can get the mean or average of this vector. Simply, we have to divide the sum using the number of elements. So we can say sum of range vector divided by counter. And we can see the mean of our range vector is 5. Well, now let's get the deviation. The deviation of our range vector. And to get the deviation of one vector or matrix or TensorFlow, we have to follow a formula. The formula is standard deviation is equal to square root of mean of or average of x. where x is equal to ABS or absolute of A, or we can say the elements of array or elements of vector minus A dot mean, meaning minus the average of array or vector or matrix, and then we have to square it. So we're saying square root of mean of x, where x is equal to ABS or absolute of square of A minus mean of A. We have the mean, and we can get the square of A minus mean of A using the square method of math module of TensorFlow. Like this: tf.math.square, and here there will be elements of our vector, so range vector and the index minus the mean. So here we can declare a variable, name it mean, and assign our mean or average here. Okay, and to get this index every time we can use one for loop. So we can say for index in range vector, we are making the square of A minus A of mean, and then we have to make this sum like we did to get our average or mean. So we can declare a variable and name it sum of square and initialize with 0, and here we can say sum of square was equal to square of A minus A of mean. We can also print it every time to check. And outside the loop we can print our sum. We're getting one error, and it's saying cannot compute sub as input 0 based was expected to be in 32 tensor but is a double tensor. Okay, we're getting this error because this value is in 32 and this one is double. So if we check here, we can see it's double or a float type. And if we check here, we can see our values are int 32. So simply we have to typecast it. We have to say tf.cast and our value, and run the program again. This time we are getting missing a required positional argument because by mistake I am not specifying the data type in which type I want to convert. So I want to convert tf.int 32. Execute it again, and it's working perfectly. We can see our sum is 110. So we have the sum of square now. At this stage we have to get the mean of x. Okay, right now we have got this one, and now we have to get this one. And to get the mean of square, simply we have to divide the sum of square by the number of elements. This is the average of or mean of x here. And now we are at the last step. we have to get the square of our mean. And we can do that easily using the tf.math module dot square root of our average of sum of square. So we can say average or mean of sum of square. Execute it and pass it here and check it. So the standard deviation of our tensor, which has elements of this, is this one, and average is 5. And interestingly, we have two methods, the reduce mean and the reduce standard. Using the reduce mean method of math module, we can get the mean or average of a vector or array or matrix or tensor. So let's try that. tf.math.reduce mean, and here let's pass our vector, range vector, and run it. We can see our average is, or mean is 5. And we can see it here. And now let's check the standard deviation using the reduce standard method of math module. So tf.math.reduce std, and our vector, range vector. Execute it. Okay. What it's saying? It's saying input must be either real or complex. Received integer d type int 32. So either we can change the data type here while creating the vector, or we can simply typecast it using the tf.cast vector, and the data type is float. Okay, just float, and execute it. And we can see it's exactly the same thing. So now we understood how to get a mean of one vector or array or matrix or tensor, whatever, and also we understood how to get the standard deviation of one vector or array or matrix or tensor. Now at this stage, let's create one tensor using the normal method of random module of TensorFlow. We can say tf.random. Let's execute it, and we can see it's a module. And now we can call the normal method of a random module, tf.random.normal. The normal method takes 3 parameters, or we can say actually 3 arguments. At first argument, it takes shape of the tensor or array. We want 2 by 3 shape, and we have to pass it as tuple 2 by 3. And then we have to pass the mean of the matrix we want to make. Let's say we want the mean of the matrix 50, and then we have to pass the standard deviation. What is the standard deviation we want? Let's say we want 10. Now let's assign it in one variable, name it random normal matrix. Execute it and print it. Awesome. Now let's check the standard deviation and mean. Well, the standard deviation of this matrix and mean of this matrix will not be exactly 50 and 10, but it will be near about 10 and 50. So let's check the mean first. tf.math.mean. reduce mean, and then random normal matrix. You can see it's 54. It's not exactly 50, but near about 50. What about the standard deviation? tf.math dot reduce steady standard deviation and random normal matrix. And the standard deviation is 7.7, which is equivalent to 8. Not exactly 10, but near about 10. Let's execute a few more time. Normal matrix. Okay. The mean, this time it's 49.48. And the standard deviation, this time it's 15.5. Okay, you can check in this ways. Now let's create one matrix. Let's create one tensor using the uniform method of a random module of TensorFlow. So tf.random.uniform. The uniform method also takes 3 arguments. At first argument we have to pass the shape. So let's say we want 2 by 3 by 4 by 5 matrix, or I'm sorry, it's tensor. And then here at second argument we have to pass the minimum value we want in our tensor. Let's say we want minimum 10, and then we have to pass the maximum value. Let's say we want 20 in max in our tensor. So let's get one variable, random uniform tensor, assign it, execute it, and print it. Random uniform tensor. Awesome. So we can see the tensor, and all the values are between 10 to 20, not less than 10 and not more than 20. And also we can get the standard deviation and mean of this tensor. Let's try that. f.math dot reduce mean and random uniform tensor, and mean is 14. What about standard deviation? Or tensor, and here is the standard deviation of this tensor. Well, we also know the formula and know how to use the formula and get it manually. If you have any confusion, you can try it yourself using the formula which we have just practiced a while ago. Hope you guys has enjoyed this lecture, so give us a thumbs up, and of course hit on the subscribe button, and don't forget to click on bell icon. See you in next lecture.